Let's start with a review of our trigonometry and our inverse trigonometry function. So we're going to have a right triangle, and it has one of the angles at 35 degrees. So I'm going to go ahead and I'm going to draw a triangle. You could draw it a variety of different ways, but I'm going to put it over here, and I'm going to put the right angle right there. Could have been either way, and it has an angle of 35 degrees. So I'm going to go ahead and draw the triangle like this, and I'm going to say that this angle is 35 degrees, and I'm pretty close to scale here, I guess. And it says the hypotenuse is 8, okay? So at this point, it asks me then to solve the rest of the items here. I don't really have very much information, but we've got enough here to figure out what this is. So I'm going to start with my SOHCAHTOA, all right? And I'll start with sine, SOH, S-O-H. So sine is equal to the opposite over the hypotenuse, all right? So here's 35. This is the opposite. And this is my hypotenuse, and that must mean that this is the adjacent right here, opposite and adjacent. So if I start right here and I go sine of 35 degrees is equal to the opposite, which we don't know, over the hypotenuse, which is 8, okay, right there. So in order to solve for the opposite right here, I need to multiply this side by 8, and I need to multiply this side by 8, so that these cancel, okay? So I get 8 times the sine of 35 is equal to the opposite. So I come right here and I go 35 and I hit sine and I times by 8. I get 4.59. Okay, 4.59. So the opposite right here is equal to 4.59. All right. Now I could do a variety of things here. If I wanted to get the adjacent here, I could certainly use cosine, and it would end up being 8 times the cosine of 35, because cosine is the adjacent over the hypotenuse, all right? Or I could use Pythagorean's theorem. Pythagorean's theorem says that a squared plus b squared equals c squared, okay? And so if I wanted to look at this, I would have a squared, which I don't know, plus b squared, which is 4.59, equals c squared, okay? So I would have that. So in order to get, sorry, that's 4.59 squared, and c squared, I'm sorry, was 8 squared, okay? Okay, so in order to solve for the a squared here, I would have to say a squared, I'd have to subtract 4.59 from each side. So 4.59 squared here is just equals to 0. So a squared equals, I'd have to subtract from this side as well, 8 squared minus 4.59 squared, and then this canceled out. Okay, and then finally, I would have to take the square root of this to get a, and if I square root this side, I have to take the square root of this side as well. So let's do it. What is the square root of 64 minus, because 8 times 8 is 64, and I got 4.59 squared. This is 21.07. So now I'm getting a is equal to the square root of 64 minus 21.07 is 42.93. The square root of 42.93 equals 6.55. Okay, so that's what this side right here would be, 6.55. Okay, finally, I need this angle right here. All right, well, there's a variety of different ways that we could do this. I'm going to use an inverse function. All right, so if I want to get this angle right here, I can use sine, cosine, or tan. And so I'll just pick tan, all right? Tan is equal, tan of the angle is equal to opposite over the adjacent. So if I go tan is equal to opposite over adjacent, tan of my angle. If this is my angle here, this side over here is the opposite. This is the opposite of it, 6.55. And that must mean that this is the adjacent, because that's the hypotenuse, 4.59. But if I want the angle, I got to take the inverse tan of it, okay? So if I take 6.55 and divide it by 4.59, I get 1.42, and I got to take the inverse tan, and I get 54.98 degrees. So it says that this is 54.98 degrees. Now, that's just using the inverse function. It probably would have been a lot easier to say, hey, these three you have to equal 180. So maybe I could have did that easier. I just said 180 degrees minus, there's 90, minus the 35. And if you do 180 minus 90 minus 35, you get 55 degrees. And those two are pretty close because I was using decimals and stuff and rounding. I got a little bit different, but 55 and 55. But I wanted to show you a little bit of everything. I used SOHCAHTOA in this first part here to use the sine to generate one of the sides. I used Pythagoras theorem to get the other, even though I think maybe cosine would have been easier. I use inverse tan to get the angle here. I could have used inverse sine or inverse cosine to get it as well. And then I also used just subtracting from 180 and then the right angle 90 to get that. So you could have done it that way as well. So when you're working these out, often there's a lot of different ways or different tools you have to solve for the other angles and sides. Typically, I just pick whichever is easiest.